Hello guys, you are welcome to Astro Digital Technologies YouTube channel. My name is Ezekiah Omoyemi. In today's video, you are going to learn how to undo data anomalies in Excel. What is or what are data anomaly? A data anomaly, also known as an outlier, is a data point that significantly differs from the majority of the data points in a data set. Common types of data anomalies include outliers, noisy data, data entry errors, seasonal or trending anomalies, and change in behavior. Data anomalies can be detected using various techniques in Microsoft Excel, such as statistical methods and data visualization. For statistical method, you can use Zscore, modify Zscore, and density-based methods. When we are talking about detecting data anomalies, outliers in Microsoft Excel using data visualization, we can use visualizations such as scatter plot diagram, box plot, and heat maps. So these are the data visualization tools that we can use in Excel to identify data points. Why is this important? Identifying and addressing data anomalies is crucial in various applications, such as data quality control, in order to ensure accuracy and consistency, fraud detection, identifying unusual transactions or behavior, predictive maintenance, in order to detect equipment or sensor anomalies. We can also apply this in customer behavior analysis when you are trying to understand unusual customer actions, and quality control, identifying defects or irregularities in manufacturing. So these are the common application of why identifying and addressing data anomalies is crucial in various applications, right? By detecting and investigating data anomalies, you can gain valuable insights, improve data quality, and make more informed decisions. We are going straight to Microsoft Excel, where I'm going to show you how you can use Zscore and Boxplot diagram to identify data anomaly. Without further ado, let us move straight to my Microsoft Excel. Here we are in Microsoft Excel. This is a sample data set. Let's call this one customer income data set. We have the age and we have the income statements. Looking at these data sets, how can we detect outlier? Let us, using statistical method, let's see how we can generate, let's see our statistical distribution. I will look for the minimum. We are looking for the minimum salary, the max, and the average, right? These are the statistical scores we are looking for. We say what? Okay, equals to minimum. We want to get the minimum income. And here will be maximum. From this same range, and we want to get our average. Now, look at our average. The minimum salary the maximum salary. Our focus is going to be on this maximum salary. Looking at this, you are looking at this income statement. Let's look at our age range. Let us try and get let's get the average age here, right? We are trying to get the average age. Let's see what we have here. Our average range is 30, and you have this. Look at this figure. No, and you are inspecting this data. All of a sudden, you saw this. You came across something like this, 25,000, right? And you are curious. How could this be? If the average salary is 2,700, $2,071, and the maximum salary is 25,000. This could be seen as a what? As an outlier or an anomaly in this data point. You want to investigate further to see that probably this is correct. What do we do? In order to do this, we are going to be using, like I said, the Z-score and the words interquartile range. We are going to be using these two methods. And what is Z-score itself? A Z-score is a statistical measurement that describes a values relationship to the mean of a group of values. It is also called a standard score, and it gives you an idea of how far from the mean a data point is. And this Z-score is measured in terms of standard deviations from the mean. And to handle this, we want to see if this is an outlier, if this is due to error or so. We are interested in this particular amount. How do we do this? Using Z-score. So we say, okay, using Z-score, what we are going to do is, first of all, we are going to calculate our mean. One, we are to calculate our mean. And how do we calculate the mean? We will simply use our average. Average is also known as the mean, right? And we are going to highlight all these data points here, this range, and press enter. Our mean value is $22,071. The next thing we are going to do is to calculate our standard deviation. We are calculating our standard deviation. So we use the standard deviation function, which is called to STDVS, which is to estimate the standard deviation based on on a sample. And we are ignoring the logical values and text in the sample. We will highlight this range as well, right? And we will press enter. This is our standard deviation, 5,926.8. 96 cents. Okay, going further, what do we need to do to calculate our Z score? To calculate our Z score, what do? We are going to simply what? Minus, we are subtracting this our data point here from the what? From the mean, and we are dividing it by the what? The standard deviation. That is how we can calculate our Z score. Now, we say what? Equals to, open parenthesis, our, this number, this particular number, amount we are investigating, we subtract it from the what? From our average, which is the mean, right? Then we are dividing it by what? By our standard deviation, and press enter. Look at this. This is around 3 points. Let me round this up. Let me round it. Yes. Okay. This 3.9 is a what? Is an outlier. This particular data point is a what? Is an outlier. So that is what the Z score is telling us here. So we cannot totally discard this. We may further ask question to know the kind of the kind of job or the profession this particular person is doing, for us to totally discard this what? This figure, this amount, right? But in a situation whereby we don't have such information, so we can simply replace this value using the words our mean. So we can replace this value using the mean, or we upfill, we upfill. Right? That is one method. Now, let us use words Boxplot diagram to investigate our outlier. I'm going to select this data range, go to the insert tab, and bring in our Boxplot. Right? Now, looking from this place, let's get rid of this. Let's just put 300 here, right? Now, okay, this is balance. Now, the interpretation of this Boxplot is this. It is simply saying that this is the X represents the what? The average data point. It simply represents the what? The average data point. Right? Why this box itself? It is talking about the what? The quartile ranges that we have. It's talking about the quartile range that we have. We have the 75th percentile, which is Q3, and we have the 25th percentile, which is Q1. Now, so the box width here represents the words, the IQR, and the height is what? Is arbitrary. So the IQR simply means what? Interquartile range. It simply means interquartile range. Going further, you can see that the data points, this is just telling us the upper boundary and the lower what? And the lower limits. These are the vertical lines. So they extend from the box, which is also known as what? Whiskers. So it represents the what? The range of values that are within 1.5 times the what? The IQR from the quartile 1, and the what? The quartile 3. Any data point beyond the whiskers, beyond these whiskers, are considered what? Outliers. And we said that the outliers are what? Are data points that fall beyond the whisker more than 1.5 times the interquartile range. And it's represented by a circle. Remember that we have 25,000 here, right? We have about 25,000 UA. Now, going back, you see that these words, these data points, it is very far from the what? The interquartile range. So, with this box plot diagram, we've been able to detect that this particular data point is what? Is due to an error. So it's an outlier. We have to get rid of it or do something about it. Let us go further to investigate what this interquartile range is actually, this box plot is actually saying. And to do this, we will say what? Okay, we want to calculate our first quartile. We want to calculate the first quartile. Calculate the first quartile, which is our Q1, right? Now, how do we calculate our first quartile? We are using the percentile function. So we say equals to percentile what? Exclusive, right? Which returns the get percentile of values in a range. Then we highlight our range from this point down to this word, to this place. This is the range. And we say comma, because we are saying the word, we are calculating first quartile, which will be 0.25. 0.25. And when you press enter, you can see our interquartile range. So our first quartile is what? This is our first quartile, right? Let us calculate. Let us calculate the second quartile, which is our Q2, right? Now, to calculate our second quartile, we are still using the same exclusive percentile exclusive what function. The percentile exclusive what function, which is from this range down to this what, and then we say what 0.75, 0.75, control enter, and here is our what interquartile, our quartile, our third quartile what range. Our third quartile what, it should be third, not second, it should be third quartile, right? How do we calculate our interquartile range? So to calculate the interquartile range, we simply say what, which is our IQR, close this and enter. It will be what, simply the difference between our what Q3 and Q1, Q3 and what and Q1, which is going to be what now equals to this point, so minus what this point, and press enter. This is our what interquartile range. That's our interquartile range. Now we want to calculate the upper and lower fence. We want to calculate the upper and the lower fence. Now the lower fence is minus 1.5, while the upper fence is what 1.5. How do we calculate the lower and the upper whisker or upper fence? Lower fence, which will be what, our first quartile, this Q1 first quartile minus what, minus 1.5, and we are multiplying it by our what, our interquartile range value. This, you press enter, right? Now, which is, let me put it here, it is Q1 minus 1.5 multiplied by IQR and press enter. That's our formula. So let us get our upper fence. Our upper fence, like we said, is going to be what? Q3. Q3, which is this. Q3 plus what? 1.5. And then we multiply it by what? Our interquartile range value here and press enter. Look at our interquartile range here. Our interquartile, our upper fence is what? This value. And in dollar. And then it's negative. Okay, so what this is simply saying is that the data point this data point that we got here is what is below the lower fence. So when this is what 2,603 is what this is far above the what is far above the upper fence. So the value here is far above the what the upper fence. That is the implication. So this is a what? This is an outlier. It's an anomaly. So this is how you use what? You use Boxplot and Zscore to detect outlier in Microsoft Excel. I hope you enjoy this video. Kindly like, comment, and subscribe to my YouTube channel. Thank you.